All right, folks, it's Bass Action, back in action here. In class, we went over how to show parallelogram properties using our algebraic rules. And in the last video, I went through 5 methods of proving that a quadrilateral is a parallelogram. So in this video, we're actually going to combine those two things together. So as we talked about in class, the very first thing we want to do is get a rough idea of where the points would land. So we're just going to quick plot them, even if they look kind of bogus and our shape doesn't look very good when we're done. So point S, I'm going to put at 4, -3, and as I just said, don't worry that this seems really far off. It doesn't seem to scale. That's okay, it's in the right quadrant. N is going to be at 3, -8, so it's going to be down here. O is going to be at 9, -1. And W is going to be at 8, -6. And we're going to connect those points. If you're listening carefully, you might hear my cat next to me. All right, so when we want to identify what this parallelogram's name is, remember that we need to pick any vertice and go around. It doesn't matter what one we start at and doesn't matter the direction we go. We just need to be consistent. So I'm going to name this one Snow, S-N-O-W. And for my first method of showing that I have a parallelogram, I'm going to show that the diagonals bisect each other. And for that, I need to be able to identify my diagonals, which is why we wanted to plot these points. So we're going to do the midpoint of SW, and we're going to do the midpoint of NO. For the midpoint of SW, we're going to average the x values and average the y values. So we're going to do 4 + 8 is going to give us a 12/2. And a -3 and a -6 is going to give us a 9/2. That's going to clean it up to a 6 and a -4.5. Now for NO, we're going to, again, average the x's, average the y's. So 9 and 3 is 12. And -1 and -8. Oh, didn't mean to close my parenthesis there. Sorry about that. All right, and then my -1 and -8 is going to be a -9, 2, and that's going to give me a 6, -4.5, which is what I was expecting. So those matched. Now, for my next method, and by the way, if you were just simply asked to prove that this was a parallelogram, once you showed those diagonals were bisected each other, they had the same midpoint, you would be done. But for the purposes of our video, we're actually going to go through all the methods. Sometimes you will be required to do a particular method, and sometimes you'll be allowed to choose. It just depends on the question. So our second method, we're going to show that both pairs of opposite sides are parallel. And I always like to organize my work for this first, and we do need to do all of them. So I'm going to first just show that I'm going to need the slope of SO. I like to put the opposite side below it. You might want to put it next to it. I'm going to do the slope of NW. Then over here, I'm going to do the slope of SN. And below that, I'm going to do the slope of OW. Again, I like to organize them this way. You can organize them a different way, but it is important that you label them. So for slope, we're going to do rise over run. So that's the difference in the y values over the difference in the x's. So for SO, I'm going to do -1 minus -3. That's going to give me a 2. And 9 minus 4 is 5. If you had done your subtraction in a different order, you would have had negatives on both of those and then would have had to clean that up. For NW, I'm going to do -8 minus -6. That's going to give me a 2. 8 minus 3 is going to give me a 5. And I can see that my slopes are the same. Now I can't stop with one pair of opposite sides. I have to do both. So I'm going to go on and I'm going to check SN. Now, I will say if these had been different, we technically could stop, but it's always good to go on and keep checking because maybe you made a mistake. So it's worth just looking at. So SN, we're going to do a -3 minus -8, and that's going to give us a 5. And 4 minus 3 is a 1, so that becomes a 5. For OW, I'm going to have 1 minus a -6, it's going to be 5. 9 minus 8 is 1, and that also cleans up to 5. So this turned out exactly as we wanted it to. Both pairs of opposite sides were parallel. So that would be another method, if you were given a choice, that you could do. Now, method number 3 is going to be to show that both pairs of opposite sides are congruent. Now, this one is typically people's least favorite, although there's always somebody who likes it, and that's totally fine. So if you're given a choice, you could do this one. But method number 3, if we're showing that both pairs of opposite sides are congruent, that means we're actually going to have to calculate the distance of each of our sides. So again, I like to put them opposite sides on top of each other. So I'm going to do SO, and I'm going to do NW, and I'm going to do SN over here, and I'll do OW below that. Now, remember, our distance formula is going to require us to have the square root. So sometimes I would encourage people just to write that square root right off the bat. And I do like to do some computations in my head. So as you're looking at your piece of paper, I'm going to work with SO first. And what I'm going to do for SO is I'm going to take the difference in the x values. So I'm going to do 9 minus 4, and that's going to give me a 5. And then I'm going to square that 5 right away, and I'm going to write down 25. Just because it's easy to do in my head, they're clean, simple numbers, and I'm less likely to make a mistake. Now I'm going to add that to the difference in the y values squared. So now I'm going to do -1 minus a -3, and that's going to give me a 2, and I'm going to square that, and it's going to give me a 4. So that's going to clean up to the square root of 29. For NW, I'm going to repeat the process. So for NW, I'm going to do 8 minus 3 is 5. I'm going to square it and get 25. And -6 minus -8 is 2. I'm going to square that, and I'm going to get 4. That also becomes the square root of 29. So I've shown that one pair of opposite sides is congruent, but I can't stop. I have to keep going. I have to do all 4 sides. So now for SN, I'm going to do 4 minus 3 is going to give me a 1. 1 squared is just a 1. And -3 minus -8 is going to be 5. I'm going to square that and write 25. So the length of SN is the square root of 26. For OW, 9 minus 8 is 1. 1 squared is 1. Add that to -1 minus -6 is a positive 5. Squared is 25. And that also is the square root of 26. Okay, so now we've shown that all 4, we've calculated the distance of all 4 sides and shown the opposite sides are congruent, so this would be another method. Now the last method is a really important method, but it is one that students often mix up. We have 2 choices on how to do this, and I'm not going to recalculate anything on this. I'm just going to organize the work and talk about it. So we need to show that a single pair of sides is both congruent and parallel. So we're going to either, and you would, if you were using this method, you would do one of these or the other. You would either use sides SO and NW, or, I'm going to put a line in the middle, or you would use SN and OW. You would not do both parts of this. You would not do this and this. You would do one or the other. but we can actually just pull our numbers from all the computations that we've done before. So let's say we're working with the using SO and NW. So if we were doing that, what we would do is we would do the slope of SO, and we've already calculated that up above, so we can write it 2/5. And we would do the slope of NW, and we also have calculated that from up above. But if you were using this method, you would have to do those computations right off the bat. And then you would also have to show the distance or the length of SO, and we've already calculated that, so I'm just going to write it down. And you would have to calculate the distance or the length of NW. So you would have 4 computations that you would be working with, but all 4 computations would be working with the same pair of sides. Now, you could also use the other set of sides. It doesn't matter, but remember, you're not going to do all of this. So if you were doing these, you would do the slope of SN, and if you calculated that, as we did up above, you'd get a 5. You would do the slope of OW, and as we did up above, you would get that to be a 5. Then you would calculate the length of SN. As we did up above, we got it to be a square root of 26, and you would do the length of OW. So this method, you would, again, if you were doing these sides, you would do 4 computations. They would all be working with the same sides. So the only method that doesn't require 4 separate calculations is the midpoint formula, even though that one kind of still requires 4 because you have to do all the x's and all the y's. So the question that I want you to think about between now and class is, which method do you prefer? I want you to, before you come in class, I want you to have chosen a method that you like. Keep it in mind that sometimes I'm going to require you to do one method or another, but I want you to have a preference and kind of know what direction you're leaning so that you can easily make a choice when you get the opportunity.